Hello class and welcome to Math Minutes, video lesson number 44. We're going to start learning about proportions, what they mean, how to figure them out. This lesson begins in notebook number 3 on page 1. So get your notebooks out, turn to page 1, and let's get started. Proportions. A proportion is a mathematical comparison. Mathematical comparison between two numbers. An example of this could be a room full of 15 students where 4 are boys and 11 are girls. This proportion of students can be written two ways. It can be written with a semicolon, 4 to 11, or as a fraction, which is 4 over 11. The comparison can be made from boys to girls or girls to boys. The numerator and the left number will be determined by what is being compared to what. That means because we did boys to girls, we went 4 to 11. And the 4 was the numerator. But if we wanted to compare girls to boys, we would have written it as 11 to 4 or 11 over 4. So what is being compared to what? Left to right or top and bottom? So let's take a look at an example. Compare the triangles to squares. Triangles to squares. That means our number on the left is going to be the triangles. Well, we have 1, 2, 3, we have 4 triangles. The squares, we have 1, 2, 3, 4, 5, 6, 7. This is a 4 to 7 ratio. Could also be written as 4 over 7. Turn to page 2 and let's see how we can compare these a little bit more. How can you tell if two proportions are equivalent? Now, equivalent just is another word for equals. If something is equivalent to something else, it is equal to it. So how can you tell if two proportions are equivalent? Well, what if I were to shade this much of the circle? Well, if we know or remember our basic fractions, we have one whole and it was cut up into 4 pieces and I shaded 2 out of 4. 2 to 4. But can you also see that that is half of the circle or 1 out of 2? These are equivalent. Well, we can see that in the picture, but what if we had a fraction that wasn't as easily illustrated with a circle cut into pieces? This is where we can do cross multiplication. So cross multiplication, let's use this one up here first as our example to prove it. Cross multiplication is we're going to multiply in the shape of a cross. We're going to multiply the 4 and the 1, and we're going to multiply the 2 and the 2. So you see how it makes a cross. Well, 4 times 1 is 4, and 2 times 2 is also 4. These are equivalent because they equal each other. So let's take a look at these two fractions and test it with cross multiplication. Is 4/5 proportionate to 8/10? Well, if we cross multiply, we know that 5 times 8 is 40, and we know that 4 times 10 is also 40. So is 4/5 and 8/10 proportionate to each other? Are they equivalent? Yes. How about 2/3 to 6/9? 2/3, is it proportionate to 6/9? Well, let's cross multiply. 3 times 6 is 18, and 2 times 9 is also 18. Yes, they are proportionate. Let's try this one down here. Is 3/5 proportionate to 6/12? Said 12, wrote 10. That won't be the first time that happens. 5 times 6 is 30. And 3 times 12 is 36. These do not equal each other, therefore No, they are not proportionate to each other. Let's take a look at the next page for a little more practice in determining equivalency in proportions. Equivalency in proportions. This is where we've been given, what if we've been given 3/5 is to something 15? Well, let's make this proportionate. And we can do that by cross multiplying to figure out what our unknown is. Well, 3 times 15 is 45. And we know that that has to equal 5 times x, which is 5x. Now, how do we solve for an unknown like this? Well, the 5 and the x are being multiplied, so let's divide that 5 to cancel. And then we have to do the same to that. So we know that x equals 45 divided by 5 is 9. So that means if we put a 9 up here, we now have equivalent fractions. Let's take a look at number 2. Number 2, what if we had something like 7/10 is equal to 14 over what? Well, let's do our cross multiplication. Now, it doesn't matter which way we go first. Let's do the 7 times the x this time, and that would give us 7x equals, what is 10 times 14 is 140, and let's divide by 7. We know that x then, 140 divided by 7 is 20. How do I know that so quickly? I know that 14 divided by 7 is 2, and then I just add the 0, which is the tens. So 20. Okay, what if we have something like, let's try another one. Well, let's just do another test. Is 2/15 equivalent to 4/40? Random numbers. Are they equivalent? Let's cross multiply. 40 times 2 is 80. And 15 times 4 is 60. These are not proportionate. So again, let's take another look at cross multiplication. Let's prove if something is proportionate. How about 5/50 is equivalent to what over 500? 50 times x is 50x. 5 times 5 is 25, and let's put 2 zeros after it. That's how I'm going to get that. And now let's solve for x. Divide by 50, divide by 50, and let's take a look at how I do this. Let's cancel out those zeros. 5 goes into 25 5 times with 1 0 left, so 50. And again, what that means is 5/50 is equal to 50 500ths. Another way to check on some simple problems like this, where the numbers aren't too complicated, is to see their proportional growth. 5 times what could give you 50? 5 times 10. And for them to be equivalent, you would have to multiply this by 10 also. And is that true? Is 50 times 10 500? Yes. So that's another way to check. All right, so let's go back to another, are these equivalent? Or let's make them equivalent. Let's have x over 30. And let's make it 2 over 15. Well, let's cross multiply. X times 15 is 15x. 30 times 2 is 60, and they should equal each other for them to be proportionate. Let's divide by 15. Divide by 15. Well, I know that 15 times 4 is 60, so x equals 4. And again, what does that mean? That means 4/30 is equivalent to 2/15. Okay, that's all there is to learning the introduction, a little bit about proportionates and how we can test to see if proportions are equivalent and how to determine what an equivalent proportion would be. So bring any questions you have to class. Good luck with your homework, and I'll see you soon.